Good morning. This video is step-by-step directions on how to do our gizmo for today. Our gizmo for today is on chemical reactions. And let me take a second here to explain the setup here. We have reactant number 1 with a drop-down menu with these choices. We have reactant number 2 with these choices. We can set up our experiment as a normal setup, which would look like this, or gas collection, which would have the gas collected from a reaction. We have labeled the reactants so that whenever we pick, it'll have a label to show us what it is. We can also show the chemical equation, and if it's not balanced, we could make it balanced. And then when it's gas collection, you'll have some extra things down here. You'll have a glowing splint and you'll have a burning splint, and you'll be able to play, pause, and reset if you need to. Alrighty, so that is our setup here. Let's look at our paper. That's not it. Let me try again. How about this one? All right, so you can see here that we have lots of vocabulary here. Most of the ones that some of these we don't need. The ones that we need, we've already gone over quite a bit. So what I would suggest is that if it is helpful to you, as I'm going through this, what I would do is pause the video and answer the questions as I'm going through it so that you can hear me read the questions to you and listen to my explanations, and then pause and rewind as much as you need. All right, so of course, all of our gizmos start out with a prior knowledge question. So you do these before you do anything with your gizmo. So a student mixes baking soda and vinegar in a glass. The results are shown at the left. Do you think any new substances are being created in this mixture? If so, how do you know? So here is a place for you to type that. Hopefully we've had enough prior knowledge that you can answer this question. So go ahead and pause the video and answer that question. All right, number 2, suppose this was done on top of a balance. Do you think the mass would change as the reaction proceeded? So do you think if you put this on top of a scale or a balance, would the mass change? Yes or no? Number 3, what do you think would happen to the mass if the reaction took place inside a sealed plastic bag? So what do you think would happen if you could measure it and keep the cup in a sealed plastic bag? All right. So let's talk about our warm-up. A chemical change or a chemical reaction occurs when one or more substances, called the reactants, are transformed into different substances or products. In the chemical changes gizmo, you will look for evidence of chemical changes by looking at the changes you see, touch, or smell. To begin, check that reactant number 1 is sodium and reactant number 2 is water. Sodium is a metal so soft that you can cut it with a knife. So you would go to your gizmo, check that number 1 is sodium, number 2 is water. So we've done that. To begin, we did that, sorry. Click play. What do you observe? So you would come over here and click play and then write down what you observe. Go ahead and do that now. Number 2, do you think a chemical reaction has taken place? So based on what you saw, do you think a chemical reaction has taken place, and explain? Go ahead and pause and do that now. All right, so activity A, to get the gizmo ready, click reset. Check and make sure you still have sodium and water. Turn on label reactants checkbox. So you would go over here and check this box. All right. It is important to distinguish chemical changes in which new substances are formed from physical changes, which do not create new substances. In this activity, you will look at many kinds of evidence that chemists use to see if a chemical change has taken place. So the question we're going to answer with this experiment, what kinds of evidence indicate a chemical change has taken place? Observe, some chemical reactions release heat and others absorb heat. In an exothermic reaction, heat is released and the temperature of the system rises. In an endothermic reaction, heat is absorbed and the temperature of the system decreases. In the Gizmo, drag the thermometer into the flask of water. So you would take your thermometer and drag it to the water. What is the starting temperature? Tells you the starting temperature right here. So you would put that right there in your worksheet. Click play and wait for the reaction to end. What is the final temperature? So you'd click the play button, watch for the whole thing to play out, and see what happens to the ending temperature. And record that right here. Go ahead and do that now. And then C, was this reaction exothermic or endothermic? So remember, exothermic, heat is released, so the temperature would go up. In endothermic, heat is absorbed, so the temperature in the water would go down. So did the temperature go up or down, and would that makes it exothermic or endothermic? Go ahead and write your answer there. All right. Two families of chemicals are acids and bases. Acids and bases can be detected by an indicator, which is a substance that changes color in the presence of an acid or a base. Phenyl red is an indicator that is yellow in an acid, orange in a neutral solution, and pink in a base. Click Reset. Drag the phenyl red next to the flask of water. What does the indicator show? So we're going to click Reset. I didn't do anything. Drag the phenyl red to the water. What does it show? Right here. So it says it's neutral. So you would go back here and say neutral. Click play and wait for the reaction to end. What does the indicator show now? So you would click play and see if there's a change here in what happens to the pH of that product. Observe, click reset, set up the gas collection setup. Chemists use this apparatus to collect any gases produced in the reaction. From the reaction flask, gas travels through a long tube into a cylinder of water. As the gas bubbles into the cylinder, the water is displaced or removed until the cylinder is filled with gas. So you can see that right here. There's that tube that goes into the water, and then the water in here will be displaced by the gas that's collected. All right, so click play and observe the cylinder. Was any gas produced in the reaction? So when you press play, does any water get displaced in this cylinder? If it does, then you could say yes. How did you know? Because the gas got displaced, or it didn't. You would say no, because the water didn't move. So go ahead and click play and then see if you observe any changes in the water in this cylinder and record it here. All right. One way to test what kind of gas is in the cylinder is to use a glowing splint. A hot glowing splint is a wooden stick that has been lit on fire and then blown out, resulting in a glowing red hot tip. The table shows how a glowing splint reacts with some common gases. So with carbon dioxide or ammonia, it'll go out. With oxygen, it'll burn brightly. With hydrogen, it'll be like a small explosion. So drag the glowing splint next to the cylinder and observe. What do you see? So you're going to play it again, and you're going to drag the glowing splint over to the cylinder. Based on the table above, what gas do you think was produced in the reaction? All right. Turn on Show the Chemical Equation. A chemical equation is a shorthand way to describe a chemical reaction. Symbols represent the elements, H for hydrogen, O for oxygen, Na for sodium. The reactants are shown to the left of the arrow and the products are shown to the right. For example, the equation H2O2 arrow H2O shows that a reactant's hydrogen and oxygen combine to form the product H2O or water. Look at the reaction shown in the gizmo. What are the reactants in this reaction? So if we turn this on, the reactants are going to be on this side. So that is what you would put in this first box. What are the products of this reaction? Well, the products we know are on the other side of the arrow. So here are the products from this reaction. Almost think of this as like an equal sign. These things equal this. The reactants, the products. All right, these symbols represent sodium hydroxide and hydrogen gas. Sodium hydroxide is a strong base. Chemicals that contain hydroxide ions are bases. How do the products of this reaction relate to the phenol red test and the splint test? So basically, we're trying to figure out, was it an acid or a base? Remember that the phenol red up here will tell you whether something is an acid, a neutral, or a base. So they want you to kind of make that connection here. All right. So now you need to reset and select hydrogen peroxide for reactant 1 and potassium iodide for reactant 2. So you would change this to this, this to this, change it to a normal setup, I think. Oh no, it looks like it has the gas. So I'm going to go back and make that a gas collection still. All right. So how does the mass change or not change during a chemical reaction? In this reaction, hydrogen peroxide is added to potassium iodide solution. Click play and observe the reaction. So you're just going to go over here and click play. What did you observe? So what did you see? Go ahead and write that. What evidence do you see that a chemical reaction is taking place? So what did you see that let you know there was a chemical reaction? Pause the video and go ahead and answer that question. All right, replay the reaction and use the available tools, the thermometer, the phenol red, and the glowing splint. What do these tools indicate? Note, you'll need to switch to the gas collection setup to use the splint. Oh, so this looks like, well, that one that has that on there. Okay, so I think it's fine. So use the thermometer. If you can't use the thermometer with the gas collection, let's see. Oh yeah, it lets you. So you're going to use the thermometer and play it and tell me what happens. Use the phenol red. What color did you get? Use the glowing splint and see what your reactions. What did it tell you? And remember, is it exothermic or endothermic? Is it an acid, base, or neutral? What kind of gas did you see? Remember, you might have to go back and look to see what those results told you. So when you get that glowing splint, what did you see? And that'll tell you what kind of gas it was. Click reset, change back to normal setup. Notice the mass shown on the electronic balance. So you're going to go back to normal setup, check the mass, record that here. Click play. What is the mass when it finished? So you would click play and then see what the mass is once the reaction is finished. How does the mass change in this reaction? Does it go up? Does it go down? Does it stay the same? Click reset and select gas collection setup. Notice that this setup is heavier than the normal setup, but the amount of the reactants is the same. So it's the same amount of reactants. It's just that this equipment weighs more. So any changes should be, it doesn't matter, is what they're trying to tell you. So what is the starting mass? How do you think the mass will change during the reaction? Click play. What is the mass when the reaction has finished? So you're basically going to do the same thing, but this time with the gas collection. All right. Activity C, you're going to click reset, select normal setup, and you're going to have sodium as reactant 1 and chlorine for reactant 2. All right. In this reaction, a small piece of sodium is added to a flask containing poisonous chlorine gas, which has a yellowish color, and sand. Water is then added to start the reaction. Click play. What happens? So go ahead and do that. Try the experiment with a thermometer. Is the reaction exothermic or endothermic? Does it release heat or does it take in the heat? Run the experiment one more time, this time watching the mass. What do you notice? Repeat the experiment, this time in the closed system. How does the mass change during the reaction now? So the closed system would be the gas collection. So turn the gas collection on. All right, a challenge question. Turn on show chemical equation. In this reaction, solid sodium reacts with chlorine gas to form a solid sodium chloride, NaCl, also known as table salt. How does this explain the normal setup increase in mass during the reaction? It's a good challenge question. All right, another experiment. Change reactant 1 to ammonium nitrate and water for reactant 2. So go ahead and do that first. Then add the thermometer to the flask and click play. What do you observe? Is this process exothermic or endothermic? And what is the equation for this process? So you would write the full chemical equation. All right, so this last page is kind of a fun page. It is a place for you to just get to explore. You get to create your own combinations. So what you're going to do is you're going to start with the first two, so sodium and water, and you're going to click play, and then you're going to put an X if you saw any of these things. So did you see a gas? Did you see a color change? Was there a temperature change, so you would have to measure it? Was there a new substance formed, which would probably be the gas? And was there light emitted? So you'd have to check the splint, the glowing splint experiment. You'd have to try that as well. And then you have to decide, was this a chemical reaction, yes or no? Did you have enough evidence to support that it's a chemical reaction? So you're going to start with these two combinations. And then from then on, you can come up with as many of those combinations on your own as you want. You can mix it up. But once again, you're going to put an X on if you see a gas being, you have to type in what you did, what you used in each one. So let's say that I decided to do, for my third one, silver nitrate and hydrochloric acid. So I would write silver nitrate here. I would write hydrochloric acid here. And then I would do my test. And if I saw a gas, I would put a check here, a color change, a temperature change. Remember, our color changes are unexpected color changes. So a new color that we wouldn't expect. Temperature change, did the temperature change? I'd put an X there. If it did, I wouldn't. A new substance formed. Was light emitted with the glowing stick? If any of those things gave me enough evidence, then I would put yes or no. So it's kind of fun. You guys can kind of play around with that one. If you have any questions, please let me know. This was a long video, I know, but I went through the whole thing. If you have any questions, let me know. Otherwise, have a great time.